So here we go. Let's take a look at the answers to this warm-up. Aw, nutters. Here's problem 1 and 2 on the projection. What I want to make sure that you make note of, you have to show me something about how you multiplied it out. If this just all of a sudden becomes this, you're not getting credit. I need to know where the heck that came from. That came from foiling this out. Those two cancel, and that's what I got. And for the second one, you had to notice perfect cubes. So CC SOPs. Cube root. Square, opposite sign, product, square. And then you can see here the sine plus cosine, sine squared plus cosine squared is in fact 1. And yes, because I was able to cancel that denominator out. Questions on 1 and 2? Any questions on those two? All right, 3 was probably the one that caused you the most difficulty. You needed to start common denominator. Now, for this one, when I multiplied it out, yep, it was kind of icky. When I multiplied this out, I had this stuff in the denominator, and it's kind of a toss-up sometimes. Am I going to multiply it out, or am I going to leave it factored? Well, dealing with this tangent, moving it towards sine and cosine, I was like, well, if I'm going to get a cosine squared from something dealing with sines, I'm probably going to need to multiply it out and hope that we get a Pythagorean identity, which is what I did. So I multiplied the top out. I know where my mistakes are. I tend to do a mistake with this negative sign a lot, so I moved that up on top so I didn't forget about it. And it keeps me from making those little mistakes. Then my sine and my negative sign cancel out. Sine squared plus sine squared is 2 sine squared. Oops, I need a little squared over here. And voila. Yes, ma'am. That's perfectly fine. Really, the only reason why I did it over here, because I realized I didn't give myself enough space. So that's it. And when I look at your stuff, I'm literally looking for pieces. I want to see, did you give me this piece? Did I have a piece with it multiplied out? Did I have a piece that had the 1 minus sine squared? Did I have a piece where it was written in terms of cosine and sine squared? For those pieces, doesn't matter where they are. Okay? Really was only because I didn't give myself enough space. There are always other ways to do it. No. That's not going to work. Thing is a factor. And just multiplying this by a positive sign and this by a negative sign is not going to give me a common denominator. Okay. All right, let's take a look at your homework. Well, actually, first, did you get these 3? Because where we're going with the rest of this unit is really going to be taking this stuff and squeezing it together with this stuff. Yep, ope. Okay, so for your homework, questions on your homework. And the hands go up. Michaela. Me. 46, okay. Let me write it down. Give me a sec. Zoinks. Never seen a 0 before. What is that going to do? I don't know. Let's see what it does. Another tricky thing here is we have x's and y's. Don't let that bother you. Just look in general. What do you think your first step would be for anything that has 2 fractions? Common denominator. So let's do that. That means I'm going to spread this out a little bit. I'm going to have cosine x minus cosine y sine x plus sine y. And then this one was sine x minus sine y. Cosine x plus cosine y. All right, in order to get a common denominator, what do I need to put into the denominator here? Cosine x plus cosine y? And that means if I put it in the denominator, I have to put it in the numerator as well. What do I need to put into the denominator on this one? So that means I'm going to need to put it in the numerator as well. Now, I'm just going to cross my fingers and pray that I don't need to worry about multiplying out the denominator and save myself as much time as possible. That means when I work this out, I'm going to give myself a freaking long line there. I will have sine x sine y plus cosine x plus cosine y. All right, so let's FOIL to the moon and back. First is going to give me what? Cosine squared x outside. Cosine x, cosine y. Inside. Minus cosine x, cosine y. Last. And ladies and gentlemen, make sure you always put the squared to the cosine or the sine. Oh my God, that took up so much room. Okay, let's try to get the rest of it in. Plus first. Sine squared x outside. Eek, I'm going to get tiny. Inside. Oops, not sine. Minus 9x. Sine x, sine y. Lurst. Oh my God, I'm out of room. Jiminy freaking cricket. As huge. Oh. Well, okay. It's huge, but I can quickly make it smaller. Boop, boop. It's more fun when you make the sound effects. Boop, boop. Sleep check. What I'm going to do for this next thing, I'm going to put my x's together and my y's together. That means I have cosine squared x, sine squared x, minus cosine squared y, minus sine squared y. All over the denominator. Do you see anything? Yes, sir? What about this stuff? That's a negative cosine squared y plus sine squared y. And I would never give you something that takes this long to just physically write down on a quiz or a test. No, you have to show it. You have to show it. Anytime you multiply it out, you got to tell me what you get. Because I've been getting people who are multiplying it out completely wrong and just writing down whatever trig identity looks similar. So I need to make sure that you understand where this is coming from. Plus, it saves you mistakes. Okay, what is this? 1. What's 1 minus 1? Boom! Math. Trig migraine in 3, 2, 1. Okay. Yeah. I'm only going to do relate towards the quiz level so that we're not spending crazy amounts of time on problems we're not going to work. No, you don't know. Tell me. No, I'm not doing that one. Thaddeus, did you have your hand up? No. No problems. Okay. So all of those, what numbers are that? So basically 43 and up, don't worry too much about. Easem. 36. 36 is a really good problem. I like 36. 36 gives us, and this will be our last one, sine beta over 1 minus cosine beta. I love writing betas. I think they're so much fun to write. 1 plus cosine beta over sine beta. The reason why I like this problem is it poses an issue that we haven't quite seen yet. This whole thing is already in terms of sines and cosines, right? Already there. And there's actually many different ways that you can handle this problem. But I notice that I have the equal sign here. I can still get a common denominator here, because a common denominator does not change the value of either side, it just changes the way it looks. So I'm going to start with what I have. And I'm going to look and see if I had to get a common denominator between those two fractions, what would I need for this one? I need a sine. And if I put a sine in the denominator, I need to put it in the numerator also. What would I need over here? A 1 minus cosine. That tells me now I've got sine squared beta over my denominator. And since my denominators match up, I'm not going to worry about multiplying that out. Now when I FOIL this out, first will give me side, side, and last, minus cosine squared. And so if I look at this, what I'm now to is these guys will cancel each other out. And I don't need to rewrite this because I haven't dealt with these two numbers yet, so I can do it all in one step. What is 1 minus the cosine squared of beta? Sine squared beta. Likewise, you could have written this if you wanted as sine squared beta is 1 minus cosine squared beta. Left would still equal the right. Okay? I didn't cross the equal sign. Crossing the equal sign is like saying I'm going to change the values on both sides. I didn't actually change any value. I just changed the way it looked. See, when I multiplied this by sine over sine, what did I multiply this equation by? When I multiplied this by sine over sine, what was I really multiplying it by? Well, what is this value here? That's just 1. So I didn't actually change it at all. I just changed the way it looked. I gave both of them new outfits. Okay? You can do 2 steps in one if they don't overact with each other. Like if I did something here and that became 1, and then I took the 1 with this, that you can't do together. Okay? I don't mind. That's fine. All right, so if I could get all my cell phones put away and all of your belongings put away, we are going to take and rock and master a quiz. For our warm-up, we did what each of these little values was. We said the sine of 90 was what? 1. What was the sine of 30? One more time. Root 3. Nope, sine of 30 is 1/2. And the sine of 60? Root 3 over 2. Does 1 equal 1/2 plus root 3 over 2? I've got half here, so in order to equal 1, this would also have to be a half. Is that a half? No, that's more than 1/2. So this is not true. This is very similar to your Pythagorean theorem. It says a squared plus b squared equals c squared. You know that 3 squared plus 4 squared is 5 squared. It's one of my nicest ones. But is 3 plus 4 equal to 5? No. The same is true when we're talking about the sines of our angles, the cosines of our angles. It doesn't work out to say, hey, since 90 is 30 and 60, I just add these two together. You have to instead use one of these formulas. So get to writing. Good news about this, I am not going to ask you to memorize these. You will have to memorize the Pythagorean identities, but these guys, I'll give them to you. Okay, so just get to writing. I know some of you are still writing. That's okay. What I want you to look at here is we're talking about the fact that not all of our angles are going to be on the unit circle. We have actually a very limited number of angles on our unit circle, so we have to have other options to kind of help us get through it. Now, it's still not perfect. It's still not going to give us everything, but it'll help me find exact values for more of our angles. Now, what I've done, and I'm not going to give it to you, because I want you to actually kind of think about doing this for yourself. We've done a lot of stuff with trig so far. So what I've put together for myself is a trig cheat sheet. This is basically where we are right now. We'll pick up some more next class. But here I have all on one piece of paper, all the things that I need to know for trig. Doing things like this can be extremely helpful. Some classes when you get to college will let you have like one sheet of notes to take your tests. It's whatever you can fit. But the thing that you need to be able to do is pick through all of the stuff that you know and find out what's the most important. What do I have to have written down? And that's what I've done here. And I would recommend that you guys, as a form of studying, do the same thing. You make yourself a page that has everything you need to know on it. I even threw in my unit circle because that's going to start playing a huge role in what we're talking about today. Now, for your tests and quizzes, I am going to be giving you these formulas, and when we get to them, those as well. You will not be given your Pythagorean identities. But having something like this available and quick to use, the more often you write it, the more familiar you'll become with everything. So I'm not going to cheat you guys out on an opportunity, so I'm not even going to post that online. You've got all the information. You should make your own sheet. And doing so over and over and over again is a great way to study. So how the heck do any of these guys get used? Well, let's start by having you write down number 1. Number 1 says the cosine of 15. Now, last time I checked, I don't have a 15-degree angle on my unit circle. So the sum and difference formulas say, if I can't do 15, can you think of 2 unit circle angles that when I either add or subtract, I get 15? 45 and 30. And so your first step for this, and I want to see this written out, I want to see you writing the cosine of 45 degrees minus 30 degrees. And believe it or not, these formulas that I'm giving you today, that's going to be the easy part of everything that we do. Because heck, I'm not asking you to memorize them. The hardest part of what we're going to do today is the unit circle. You got to know your unit circle. So, looking at the cosine and seeing that I have an angle minus an angle, that tells me, here are my cosine formulas. Here's the one where it's an angle minus an angle. So what I'm going to do is I'm going to write cosine of the first angle times cosine of the second angle plus sine of the first, sine of the second. And I'm just going to do that with these numbers. That means I have the cosine of 45 degrees, cosine of 30 degrees, plus sine of 45 degrees, sine of 30 degrees. And that, my friends, is all that is new for today. From here on out, we're using your unit circle. Some of these guys are really nice. Like, I don't know about you, but I love it when I see a 45. Because what is the sine and cosine of 45? Root 2 over 2. So I don't even need to work very hard for that. That's just root 2 over 2. That's root 2 over 2. The other ones I need to think a little harder on. What is the cosine of 30? One more time. Root 3 over 2. And the sine of 30? Then what you need to do is you're going to look at this problem and say, all right, what is root 2 over 2, root 3 times root 3 over 2? Root 6 over 4. Beautiful. What is root 2 over 2 times 1/2? Root 2 over 4. And you always want to simplify this as much as possible, which means give me just one final answer. And when we do that with this, common denominator, I will have root 6 plus root 2 all over 4. And root 6 plus root 2 does not simplify any further. Sometimes the hard part is just going to be the unit circle part. Sometimes the hard part is going to be the arithmetic. I'm hoping you never say the hard part is this stuff. That's my hopes. Okay? Keep this to as little new as humanly possible. All right. Let's do another one. Go ahead and write down the sine of 165. And try to think of what two angles can I combine in some way to get 165. Unit circle angles. There's a really, really big hint here. Which one of my unit circle angles ends in a 5? 45. 45 is one of my unit circle angles, right? So I'm going to write this as the sine of 45 degrees plus what? 120. Is 120 one of my unit circle angles? Sure enough is. Now that I've got it broken down, I can say I'm looking for sine and plus. So looking through my formulas, sine with a plus. I'm just going to use that formula. Sine of the first angle times cosine of the second plus cosine of the first, sine of the second. That works out to be, let's see here, sine of the first, sine of 45, cosine of the second, cosine 120, plus cosine of the first, sine of the second. Yay, unit circle. Again, I get my 45s. Those make me happy because what is the sine and cosine of 45 degrees? Root 2 over 2. Now, when we think of 120, what is the reference angle that goes with 120? 60. And we know cosine is the x and sine is the y. So for 60 degrees, what is the x? What is the cosine of 60? 1/2. Then what is the sine? But this is not 60, it's 120. So what quadrant is 120 in? The second quadrant. And so for the second quadrant, what are my signs? Negative, positive. And if you want, you can always say, well, 45 is root 2 over 2, root 2 over 2. 120 is 1/2 root 3 over 2, and in that quadrant, it's negative, positive. So if you want to write those coordinates down, because you're going to use both pieces, that's fine. You do what you need to do. Then we just, yes? Cosine of 120, because the cosine of 120 is negative 1/2. Cosine is x. Goes alphabetical. X, y, sine, cosine, sine. It's the only way I remember it is I think it's alphabetical. All right, so then we do the arithmetic with it. What is root 2 over 2 times negative 1/2? Negative root 2 over 4. Root 2 over 2 times root 3 over 2? That means my combined answer, and I don't care which order you write this in. Some people don't like having a negative out front. That's fine. You can do root 6 minus root 2. You can do minus root 2 plus root 6. But there's your answer. Okay? All right. On number 3, that looks pretty freaking horrible, doesn't it? Because 85 is not on the unit circle. Neither is 25. And I'm looking at that going, oh dear Lord, please no. But I'm happy to tell you this is actually an extremely simple problem. I have cosine, cosine plus sine, sine. Do you see that anywhere in any of my formulas? Right there, right? Cosine, cosine plus sine, sine. That is the formula for cosine of an angle minus the other angle. That means I can take this down here and say this is the cosine of the first angle, and we said when we did it this way, that's minus the second angle. And what is 85 minus 25? Look at that. Look at that. What is the cosine of 60? Done. It's backwards. Yep. It's saying, okay, well, sometimes they might give you the formula stretched out, and you'll need to do the exact opposite. The key to me was, holy crud, that's huge, plus the idea that 85 and 25 are not unit circle angles. So that was my big light bulb moment. It was, dear Lord, what is that thing? And then, hey, look at what we can do. And again, I'm not going to ask you to memorize these. What I am asking you to recognize is when we have this plus and this stuff going on here, maybe it's one of my formulas. These first two problems, actually these first three, dealt with angles measured in degrees, but it doesn't matter what they're measured in. You can do it just as well when your angles are measured in radians. So go ahead and write down problem number 4. And people tend to go, oh no, it's a fraction. Okay, pi over 12. I don't know, last time I looked, are there any pi over 12s on your unit circle? Nope. That means I'm going to be using my combinations of something. I'm going to want to rewrite this as the tangent of some combination, either with addition or with subtraction. The easiest way to think about this is just to deal with the 12. That means I'll have a 12 here, and I'll have a 12 here, and the number in front of the pi is what? 1. Number in front of pi is 1. Are there any numbers where you can say this number plus that number or this number minus that number gives me 1? 2 pi over 12 minus pi over 12? Problem with 1 pi over 12, I don't have that one on my unit circle. So 2 and 1 doesn't work. 4 and 3? And if I put 4 over 12 and 3 over 12, will that get me unit circle answers? Yeah, so I'm going to do 4 and 3. You could have done 3 and 1. I'm sorry, 3 and 2. 3 and 1 does not give me 1. 3 over 12 and 2 over 12. You could not do 5 over 12. Because that's not going to simplify to a unit circle angle. These will. And what sign goes between them, addition or subtraction? Okay. Well, I knew that I had it over 12. And I wanted to think of two numbers that would combine somehow to give me 1. 4 minus 3 is 1. We used 4 and 3 because if that's over 12, those both simplify. 5 wouldn't work. 1 wouldn't work. So I have to use the numbers I've got. With that, I can simplify this and say I am now thinking about this as saying the tangent, what is 4 pi over 12? Pi over 3, beautiful, minus pi over 4. That means I am just going to go back and look at my formulas here. I have tangent and I have minus. That means I will be using this formula. So translating that directly, that means that I now have tangent of the first angle minus tangent of the second angle over 1 plus tangent of the first angle times tangent of the second angle. That's all that's new for today. And that should be the easiest thing that you do. Because again, I'm not asking you to memorize. Just identify. The hardest stuff is going to be your unit circle and your arithmetic. Thinking about pi over 3. What is the tangent of pi over 3? These are things you got to know. Root 3, yep. So that's going to be root 3 minus, what is the tangent of pi over 4? Ooh, I love the pi over 4s. 1 over, and I've already done these, so I don't need to do them again. I'll say 1 plus root 3 times 1. Just kind of cleaning that up a little bit. That's root 3 minus 1 over 1 plus root 3. And now the arithmetic gets to be fun, she said sarcastically. Why am I not done here? Yeah, you've got a root in the denominator. Radical in the denominator cannot be. Does anybody remember how to handle this when it's not just a radical, but it's something plus or minus a radical? Not multiply by the whole denominator. 1 minus root 3. Beautiful. Do you guys know what that's called? That's called the conjugate. That means I'm going to take the conjugate of the denominator, and I'm going to multiply both the numerator and denominator by it. That has to be the same on top and bottom, because anything over itself is what? 1. So if I had put root 3 plus 1 up here, that would not have been timesing it by 1. It would have been timesing it by something else. That means, again, when you have a radical in the denominator, multiply the numerator and denominator by the denominator's complex conjugate, by the bottom complex conjugate. That means I'm going to have to FOIL. But you can do that. You're awesome. What is root 3 times 1? Root 3. Root 3 times negative root 3. Minus 3. Negative 1 times 1. Negative 1. Negative 1 times negative root 3. Keep on foiling. 1 times 1. 1. 1 times negative root 3. Negative root 3. Root 3 times 1. Plus root 3. Root 3 times negative root 3. Minus 3. We get some happy joy stuff happening here. This minus root 3 and the plus root 3, those cancel each other out. When I simplify what's left, what is negative 3 minus 1? Negative 4. What is root 3 plus root 3? One more time. 2 root 3. Good. And 1 minus 3? Negative 2. Are you done? No. Why not? It simplifies. Negative 4 divided by negative 2? 2. Positive 2 divided by negative 2? Negative 1. Right. So take a look at the whole problem. The new stuff was just this. Just to let you know that new isn't always bad. Sometimes the old is still bad. Arithmetic will get everybody. You want to make sure you're very careful with your arithmetic here, watching your signs, watching how you multiply, being very careful as you work that out. That is going to be the hardest stuff that we do. Go ahead and write down problem number 5 for me. So I've got a couple of problems with this, a couple of issues. Tell me one of my issues. It's cosecant. None of my formulas, I don't believe, had a cosecant in them. Is that correct? So I can't use cosecant. What will I be using? Sine. Instead of using cosecant, I need to think of this as 1 over the sine of 75 degrees. But it's not even as simple as that. Is the 75 degrees on my unit circle? No. There are all sorts of ways that you can come up with something that'll make you 75. Give me one. 30 and 45, okay. That means I now have 1 over the sine of 30 degrees plus 45 degrees. Make sure you're giving me those degree symbols. Which in terms of sine and plus, find sine and plus on your formulas. Did you find it? I'm going to write this as 1 over sine and plus. What does the formula tell me to do? sine of 30 cosine 45 plus cosine 30 sine 45. I really should have done that on the other line. My bad. And going for the unit circle with us. Going to figure out what those pieces are. What is the sine of 30? Beautiful, 1/2. You want to be nice and quick, just like that. What is the cosine of 45? What is the cosine of 30? And the sine of 45? Which means that I have 1 over, what is the product here? Root 2 over 4. What is the product here? Now, ladies and gentlemen, it's an interesting way of calling you all. Ladies and gentlemen, do not then tell me for the next line that it's 4 over root 2 plus 4 over root 6. You cannot do that. You cannot do the reciprocal until you have just one term. That means I have to add these guys first. So I will have 1 over root 2 plus root 6 over 4. Now I have a fraction, a number divided by a fraction. But we don't deal with it that way. What do we do? Multiply by the reciprocal. So now I can say 4 over root 2 plus root 6, which is not the same thing as 4 over root 2 plus 4 over root 6. Just making sure that you guys know those are not the same thing. And we've hit another arithmetic snag. I know, heavy sigh. What's wrong here? Yeah, we've got those radicals on the bottom. What will I need to multiply the top and bottom by? Root 2 minus root 6. The complex conjugate says same beginning and end terms, opposite sign in the middle. It gives us a difference of squares. Now I just get to multiply it all out and really hope that I don't make a mistake. Multiplying this out, what will my numerator be? 4 root 2 minus 4 root 6. Now the denominator, what will the first give me? 2. Outer minus root 12. Inner plus root 12. Last minus 6. Let's simplify that again. So I have 4 root 2 minus 4 root 6 over the plus and minus root 12 cancel out. What is 2 minus 6? Negative 4. That means to finish this off, I need to simplify yet again. What is 4 root 2 over negative 4? Negative root 2. What is negative 4 root 6 over negative 4? plus root 6. I'm just going to set these guys side by side. For this one, the difference here is we did 45 plus 30. So we did the order differently. But if you look, you get the same answer in the end. Okay? All right. Would you agree with me that the ugliest stuff on all of that is going to be the arithmetic and the unit circle? Yeah. Keep that in mind when we look at this one. Go ahead and write that down. After that quiz and after those 3 days on trig identities, you're probably looking at this going, I don't want to. Is that kind of correct? This is not bad at all. This is actually very straightforward. Do not let this intimidate you. Can I do anything with this? Nah. Can I do something with this? Yeah, I have a formula for that, don't I? So take a look at your formulas, and I want you to tell me what this can be rewritten as. Cosine of pi over 2 times cosine theta, not plus, minus sine pi over 2 sine theta. And it still feels weird. Because I know I need to get down to just this little thing, but look at all of this stuff. Watch how simple this is. What is the cosine of pi over 2? Pi over 2 is 0. That's 0. What is the sine of pi over 2? 1. Yeah, so that's minus. What's 0 times anything? 0. Hey, look at how straightforward this was. I just have negative sine of theta. Boom. Shakalaka. These verified trig identities are not going to be horrible because we like this, because when you have numbers in here, it's going to go away. I'm going to give you something where the value is a 0 or a 1. Okay? Just makes life easier. Go ahead and write down number 7 for me. Actually, go ahead and do number 7 for me. Yes, sir. Negative 1 times sine. Nope. This stuff is in parentheses. This stuff is in parentheses. Okay? All right, see what you can do for the tangent problem. All the flip-flopping around to look at those identities. Did you guys get it? Almost? Here we go. Boom! The key to this was the fact that tangent of pi is just 0. And then everything gets real pretty real fast. Questions on that? Where did the negative come from? The formula. The formula said for tangent with a subtraction, it's a minus on top and a plus on the bottom. Okay? Anybody else? Hopefully you're seeing that with this, the verify or the establish or the prove, those guys are not going to be too horrible. What's going to be horrible is the arithmetic and all the unit circle stuff. And I can actually incorporate this in many, many different ways. Like this. Go ahead and write down number 8 for me. We're going to do 8, we're going to do 9, we're going to stop. There is so much going on in this problem. Look at that. We've got inverses, got unit circle values, we've got addition, we've got a headache. So much, right? Let's just work our way inside out. Let's see what we can do. Can we make this less of a pain? When we see an inverse, that's telling me I'm looking for what? A coordinate or an angle? An angle. So what angle has a sign that is a positive 1/2? One more time. Pi over 6. Good. Or 30. When you write pi over 6 and 30 at the same time, it becomes pi over 3, which is wrong. Or pi over 60. So, yes, we have moments. And you know what? Since I've got an addition sign here, let's just do with a degree. Maybe that's going to be easier. So that is 30 degrees. You know, I want to make sure I get a chance to write every way of possibly doing this. What angle has a cosine of 0? Not 0. One more time. Pi over 2 or 90. I just thought you'd rather do this addition with the numbers. Now, you are perfectly fine if you'd like. I don't like. But you can go through and you can use one of your formulas. But before you go crazy, what is 30 plus 90? Is 120 a unit circle angle? Oh my gosh, let's make life easier. What is this sign? Okay, so 120 has what for a reference angle? Pi over, and I don't care which one you do. You can say either pi over 3 or 60 degrees. I don't care. What is the sine of either one of those? Root 3 over 2. 120 is in which quadrant? Second quadrant. Is sine positive or negative? Sine is positive. Boop. Darn. What we're seeing here is that when you're doing trig, nothing ever dies. It doesn't. It doesn't go anywhere. It just keeps coming back to haunt us. Which is why we take a midterm so we never have to see it again. Happy moments. And we're just going to do one. This is about as hard as these identities will get, so go ahead and write that down. Then I will show you your homework, and we will call it a day-o. That does look kind of scary though, doesn't it? Because we've got two angles in there. We have theta and beta, and sine and cosine. Oh my God! Change them. We can do stuff. Anybody have any idea, any clue? Where do you want to go first? Sine? Because this guy has a formula, doesn't he? If I look at my formula sheet, the sine of an angle minus another angle, what does that look to be? Sine theta, cosine beta, minus cosine theta, sine beta. That's right. Oh, that's a theta. Thank you. Thank you, thank you, thank you. Now you have several different ways that you can go from here. Do you want to work the right side? Do you want to work the left side? One more time. The left side? Well, if I look here, this has got two pieces. Can I turn this into two pieces? Yeah, I can. I can do that because I can write this is one fraction, that is another. Sine theta cosine beta over cosine theta cosine beta. And then I will have minus cosine theta sine beta over cosine theta cosine beta. What do you see? What do you see? What happens? I can cancel out. I can simplify. Cosine betas simplify away. Cosine thetas simplify away. What is sine over cosine? Tangent. Such a tangent. What is sine over cosine? Tangent. Boom. Wasn't too terrible, was it? Don't get freaky. It's all okay. Your homework for tonight is actually going to be in your textbook. Oh, God. Ugh. But you can do it. And we are done.